Hi, this is the second part of the video where we learned how to solve and graph linear inequalities. In the first part, we explained the rules, we do some simple problems. In the second part, we're going to do more problems that has to deal with fractions, where we have to deal with fractions. So here, this question says, solve and graph the below inequality for the following replacement sets or domains. Now the domain just means x values. So we have to solve this problem for two types of domains. The first one being x the set of real numbers, and the second one x the set of positive odd numbers. So let's try the first one. So in order to solve this, we are going to first solve it just like how we would solve a regular equation. We're going to bring all the x on one side of the inequality and numbers on the other side, and then we're going to solve from there. So positive x plus 3, I have to subtract x over 3 on both sides. I have to take away x over 3 on both sides. And I have to bring this negative 5 on the right side. So I have to add 5 on both sides. So what happens here is they're going to cancel, and negative 5 and positive 5 also is going to cancel. So here we're going to be left with x over 2 minus x over 3. And on this side, we know that negative 4 plus 5 is just 1. So at this point, we are going to just deal with this as fractions with different denominators. So we get the LCM as 6, and we multiply it to each fraction. So we get 3x on this side and 2x on the other side. That's just how you deal with fractions. I don't know if I want to explain that on the side. So the common denominator is 6. So when you multiply with 6 on either side of the fractions, 2 crosses away 6, we get 3. And that's why we have 3x here. And 3 goes into 6 twice, and we get 2x there. That's how I get this calculation. So 3x minus 2x is just 1x, or in other words, x divided by 6 less than or equal to 1. So to delete this or to get rid of this denominator over here, we multiply by 6 throughout. So when we times by 6 times 6 on both sides of the inequality, the 6 and 6 will cancel. And our final answer, sorry, let me delete this part over here so I can have some space to explain. So my final answer will just be x less than or equal to 1 times 6 is 6. That's times. So this is the solution that we got, x less than or equal to 6 including 6, that means. So on a number line, for the first part, for the first set here where x is the set of all real numbers, if this is the number 6, I can include 6, so that should be a darkened circle, and all the numbers that are less than 6. So we move to the left. The left side has numbers less than 6. So that's the solution for the first one. Now what if the second one says you need the set of positive odd numbers, positive and odd numbers. So here we know that for the second part, we know that 0 starts here and you have 1, 2, 3, 4, 5 and 6, and that's how it goes. So positive numbers kind of ends over here in this part, right? And all the numbers below 0 are negative. But we only need odd numbers. So we only need 1, 3, and 5. So the solution set for the second part is a set of 1, 3, and 5. So the first set of solutions are really called general solution, or that gives us all the solutions that are out there. And the second one is when we put a restriction on that solution set and say that we only need certain kind of solutions, and we pick that. So sometimes on a test they'll ask you to find all the solutions. Sometimes they'll give you conditions like these, like the second type. Let's do another problem. Solve and graph the below inequality given that the replacement set or domain is a set of real numbers. So here we have an inequality which has 3 parts. But if you look at this inequality, we can see that we have a variable or a x only in the middle part of the inequality. If that's the case, we can solve this inequality in one step. What I mean by that is we don't have to divide this inequality into 2 parts. and then solve each one individually like we did another problem in part 1 when we had a 3-part inequality. So before we deal with this problem, if you look at this question, you can see that there is a mixed fraction here. We have 1 and 1 over 3. Let's change that to an improper fraction first. 1 times 3 is 3, plus 1 is 4, so it's 4 over 3. Negative 1 over 3 here, and less than or equal to x over 2 minus 4 over 3 less than 1 over 6. Now we have to isolate the variable in the center part or in the middle part of this inequality. So we do that by cancelling the negative 4 over 3. So we add 4 over 3 throughout this inequality. Plus 4 over 3 plus 4/3 plus 4/3. And then this gets cancelled. So this is my less than or equal to sign. This is my less than sign. I'm only left with x over 2 in the middle part of this inequality. The left side, let's do that over here. Minus 1 over 3 plus 4 over 3. Since the denominators are same, we can just combine the numerators. Negative 1 plus 4 is 3. Divided by 3, the answer is 1. So the left side of this inequality becomes 1. On the right side, 1 over 6 plus 4 over 3. Since the denominators are not the same, let's make it the same by multiplying by 2 to this fraction in the numerator and denominator. So we get that as 1 over 6 plus 4 times 2 is 8 over 3 times 2 is 6. Now the denominators are same. So 1 plus 8, we can combine that and make it 9 over 6. As we reduce the 9 over 6, they can be reduced by 3 because 9 is 3 times 3 and 6 is 3 times 2. So we reduce that as 3 over 2. Now, if you look here, you can see that there are fractions on in the middle and the right side, but this is not a fraction. We'll make it like a fraction like that for now in order to simplify it. So we're going to multiply by 2 throughout this inequality times 2 times 2. So here 1 times 2 is just 2, less than or equal to. These 2's get cancelled and you just get x. Less than, the 2's get cancelled and you just get 3. So that's our final solution for this problem. Since it says that the domain or the replacement set is a set of real numbers, we can include all the solutions that are here. So if I would try to graph this on a number line, I have a number line like that, and I have the number 2 over here and the number 3 over here. We know that x is less than 3 without including 3 because there's no line below here. So it's an open circle and it's going below 3, but x is greater than 2, but it includes the 2 since there's a line. It's greater than or equal to 2. So that's a darkened circle right there, and we can connect it. Okay, so this is how it's going to look. The graph is going to look for this problem. So let's do another problem now. If the replacement set or domain is a set of integers, solve and graph the following inequality. So we have 3 greater than or equal to x minus 4 divided by 2 plus x over 3 greater than or equal to 2. So again, since we have x only in the middle part of the inequality, we can do this in one step. And since they are fractions, let's start by combining the denominators. So I'm going to simplify this now. 3 greater than or equal to, in order to make the denominators the same, I'm going to take the common denominator, which is 6. I'm going to multiply this with 6 and this with 6. Okay, so we know that 2 goes into 6 3 times and 3 goes into 6 2 times. So I'm going to multiply with 3 to the x and 3 to the negative 4. So when we distribute the 3 in here, we get 3 times x is 3x, 3 times negative 4 is negative 12, plus 2 times x will be 2x, greater than or equal to 2. So that's what I did. Okay, I don't know if this calculation is clear. Because they're fractions, I'll just do it on the side one more time. We have x minus 4 over 2 and x over 3. So to make the common denominator, we cross multiply, right? We take this 3, that's another way to think about it. We take this denominator and multiply it up and down like that. And we take this denominator 2 and we multiply it to this fraction times 2. So we get 3 times 2, this denominator is 6, 2 times 3, this denominator is also 6. And we distribute the 3 here, so we get 3x minus 3 times negative 4 is negative 12, and then 2x. This is what I did over here. Now let's combine our x. 3x plus 2x is 5x minus 12 divided by 6 and greater than or equal to 2. So that's what I have there. Let's continue to solve. We have a denominator of 6 only in the center part of this inequality. So to get rid of that, we're going to multiply by 6 throughout. So multiply by 6. Remember, when you multiply by 6 here, remember to put parentheses. Multiply by 6 and multiply by 6. So 6 times 3, that's 18, greater than or equal to, the 6 will cancel here, and you will get 5x minus 12, greater than or equal to, 6 times 2 is 12. Now let's solve for x. So first we get rid of the negative 12 by adding 12 throughout. Adding 12. So 18 plus 12, we get 30 greater than or equal to 5x greater than or equal to 24. 30 divided by 5 is 6, and 5 divided by 5 is 1. We don't actually write that 1 over there. And 24 divided by 5 is 4.8. So that's what we get. Our solution is, you have 4.8 over here, and you have 6 after that. So x is less than or equal to 6, and if I start reading from x is greater than or equal to 4.8. So it includes both the numbers, so I'm going to shade the circles in for both, and it's greater than 4.8 and less than 6. So that's the solution set or the graph for this inequality.